Through the struggle of having tests, assignments, and big projects, we have made it through. We are almost there to the point of finishing this course.
Hello! From what is said in the introduction, this is the last part of the quarter. Yay! So, it's also the end of the year, so in this video, I'll be talking about what we've studied in the second part of quarter 4, which is all about trigonometry and its functions. And it is also on how we apply them into many shapes, including in real life, in terms of my big project, separated into 2 tasks. So hold on. Before getting into trigonometry, we would want to know like the measurements of its shapes, thus its units. In trigonometry, there are 2 units we can use consisting of radians and degrees. So, in terms of radians and degrees, 180 degrees equals to pi radians. Therefore, 1 radian would equal 180 divided by pi degrees. So in this case, this equals 57.29 degrees. In terms of conversions from radians to degrees, you can multiply from the given radian with 180 to get the unit of degrees. As shown, if you want to convert the unit from degrees to radians, what you have to do is to divide the given degree over 180 and multiply it by pi to get the answer. But other than like all the degrees and units, we would also want to know the area of or the lengths or circumferences of specific shapes, since it's like the basic of geometry right before we get into trigonometry. The area is the measurement of what is inside a certain shape. To find the total area of the circle, we use the formula pi r squared. But in terms of trigonometry, we don't want to find the area of the whole circle. We usually cut the circle into a slice, and that is the area we want to find. In this case, we use the formula 1 over 2 times the angle radius squared. Another component would be the circumference, or the total distance around the circle. We use the formula for finding the whole thing as 2 pi times the radius, but as a part of it only, we use the formula of the angle, referred as theta, multiplied by the radius. Finally, moving on to trigonometry, there are 3 main components you have to know consisting of sine, cosine, and tangent. To find the sine of an angle in terms of a right triangle, you divide the measurements opposite from the angle to the hypotenuse, or preferably to the longest side of the triangle. In terms of cosine, it is the adjacent over the hypotenuse. It is like the opposite of sine. In the terms of tangent, it is the opposite side over adjacent. This is like the father of the 2. Trigonometry has its specific laws into solving different types of problems, whether it is to find the missing angle of a certain situation, or as might as well the unknown length of the situation. So there are 2 laws we want to know. In this case, it is the law of sines and the law of cosines. The law of sines is usually applied when we want to find in terms of the missing distance when at least 2 of the angles are given. The formula is sine A over A equals to sine B over B equals to sine C over C, and so on. Moving on to the law of cosines, it can be applied to find the distance when at least 2 of the measurements are given, but only one angle is given. The formula is c squared equals a squared plus b squared minus 2ab times cos c, which is the angle opposite to the distance we're trying to find. Trigonometric functions are often used to show data which is plotted out periodically, which in most cases, everything is based on a specific period on in an amount of time. They can be separated into two types, which are cosine functions and sine functions, in which later on I will tell you what factors make them different. So, there are many components you need to know right before being able to write the trigonometric function itself, which then I will talk about in the video on how you find it. Trigonometric functions come in two categories. One being the sine function, which has the starting point at 0, 0, and the cosine function, which has the starting point anywhere on the graph but 0. The formula into writing the function is f of x equals a cos or sine either one bx plus c plus d. A is the amplitude of the function, in which it determines the distance from the midpoint to either the maximum or the minimum of the function. To find it, you subtract the maximum and the minimum y coordinates and divide it by 2. B equals to 2 pi over the period. The period is the distance from one maximum to the other. It is found by subtracting the maximum and the minimum x coordinates, in which you multiply by 2 to find the period. C is what we call the phase shift, which it equals to negative c when we put it onto the equation. It is how far the function is horizontally to the right of 0, 0. D is what we call the vertical shift. It is also known as the midline of the function. It is how far the function is vertically from 0, 0. After knowing all of the components, you will be surely to write the correct function in terms of trigonometry. In this part of the big project, which is part 2, it is separated into two tasks again from the fact that trigonometry is a wide topic. Task 1 is where the basics of trigonometry along with the laws of sines and cosines are applied. In my case, I applied to the game of tennis. A player hits a ball with a specific angle, with her opponent standing in one corner of the court. The distance of her opponent runs to get the ball will be found out with the use of the law of cosines. With also the help of technology, the software GeoGebra, it is helped to ensure that my graphics are accurate and well organized. The second task of this project is to think of a period situation where the data must be collected and be applied into modeling the situation of using trigonometric functions. In this case, I gathered data, which is the temperatures of New York City through 1 year. Using trigonometric functions, in this case, I used cosine functions. The amplitude, period, phase shift, and the vertical shift is figured out, as shown, along with the equation of the yearly temperature of New York City.